So there's a few things that have to happen in order for a matrix to have an inverse. I'm not mad it got canceled, I'm just not going to move it. Alright, so the first qualification is that a matrix has to be square. Okay, second qualification is that when you take the matrix times its inverse, it has to give you what's called the identity matrix. So meaning zeros except for the diagonals, which are 1. And if you pair and augment the matrix with an identity matrix and then reduce it, what you'll get is your inverse. Alright, so if I look at 2, I'm going to find the inverse of that matrix. -1, 4, -1, 3. Okay, so our third thing said that third step to inverses says that if we augment our matrix with our identity matrix and then reduce, we can find our inverse. Okay, so how do we reduce matrices? In your calculator, you do it in your calculator, but how do you do it once it's in your calculator? Okay, well that's the first step. Yes, you have to plug it in.
Edit. So this 2x4.
Mm-hmm.
The numbers. You guys have to pick for that.
For the line? No, use enter.
Quit. HD. RREF. Second. HD.
No, use the RREF one.
Second.
Everybody there so far? Right. I assume that Kelson put this in right. Acceptance. Did you do it right? Okay. Alright, so then if everything comes out right, then you should reduce this, and then this second half becomes your inverse matrix. Is that what everybody else got? No. Okay, so
1, 0. Oh, I put a 2 instead of 1.
Oh, okay. See what happens when I assume you did it right? Okay, so what is my actual then? What do I actually get? 1, 1. Okay, so then your inverse matrix is just the second half of that. So -3, -4, 1, and 1. Okay, so yep, that's all this is. So I'm going to do the same thing for the matrix 1, -2, -1, 3. We have to augment it with our identity matrix. And then we're going to reduce it, and then let me know what you get. This is always your identity matrix, where you just have like ones going down, and then you just fill in the blanks with zeros. So depending on how big you make it, you could have it like be a really big matrix or really small. Alright, so what do we get for then our second one? 1, 1. Okay. So that means then that our inverse function, our inverse matrix is 3, 2, 1, and 1. Okay, we'll do one more big one and then you guys can get started just to see what a bigger one looks like. Alright, so the first thing I have to do is take my matrix. So 1, -1, 0, 1, 0, -1, 6, -2, -3. And I have to augment it with my identity matrix. And then reduce it using your RREF function. Alright, so what do I get for then the second half of my reduced matrix?
-2, -3,
Alright, is that what everybody else got? Taking that as a yes. So then -2, -3, 0, 0, -3, -3, -2, -4, 0 is going to be your inverse matrix. Okay, it's the same process but bigger matrices than 2 by 2, so you just have to make your identity matrix bigger. Okay, so we're going to do 13 through 30.